Next chapter which we are going to start here is that is your maxima minima. This is the most important chapter of application of derivatives. For curve tracing or for other applications, even for integral or for differential calculus or for differential equations, this is the most important chapter of application of derivatives. So that is maxima minima, oblique minima. Now, as the name suggests, we are supposed to find here the maximum value and the minimum value of the function at different points. First, we need to understand the meaning of maxima minima. Now, let fx be any function defined in the interval a to b. Let there exist any point C in the interval a to b such that fx is less than or equal to f of c for all x belongs to ab. That is the value of the function at every point in the interval a to b is always smaller than the functional value at c, which clearly shows that this is the maximum value here. This implies fx has maximum value at x is equal to c in the interval a to b. So this way we say that function has got the maximum value. So similarly, let x is equal to d be any point in the interval ab such that fx is greater than or equal to f of b, f of d for all x belonging to the interval a to b, then f d is the minimum value of fx in the interval a to b. Now listen, not necessarily that every function is going to have the maximum value as well as the minimum value. You can find numerous functions having only the maximum value or the minimum value, or maybe both, or may not be having any maximum or any minimum value. So first of all, let us try to discuss the that is the maximum and minimum value of the functions through certain graphs. Now let us consider the first function. Let's say it is fx is equal to, it is 3x square plus 6x plus 8. We all know that it is a parabola here because it's a quadratic second degree curve, it's a parabola here. So if you complete the whole square of this, you can see that it is 3 times x square plus 2x plus 1 minus 1 plus 8 over 3. It is 3 times x plus 1 whole square plus 3 times it is 5 by 3. That is your y, or y minus 5 is equal to 3 times x plus 1 whole square. So which means that x is equal to minus 1 and y is equal to 5 is the vertex. So this is the graph of the function. So can't we say that we have the maximum value at x is equal to minus 1, and what is the maximum value? Maximum value is 5 here. That is, at x is equal to minus 1 we have the maximum value and the maximum value is 5. So you can see that, or this implies the other way around to use this method to see whether we have maximum or the minimum value. Fx is equal to 3 times of x plus 1 whole square plus 5. Now because x plus 1 whole square is greater than or equal to 0, 3 times x plus 1 whole square is greater than or equal to 0, 3 times x plus 1 whole square plus 5 is greater than or equal to 5. So this implies fx is greater than or equal to 5. How do we get 5? We get 5 only when you take x is equal to minus 1. So this implies that fx is greater than or equal to f of minus 1 here. So you can see here, that is fx is less than or fx is greater than or equal to f of minus 1. So that implies that this is your function has got, now let me check once again this function. So this is your this is the only maximum value here. So that is fx is greater than or equal to minus 5. So that is function has got maximum value which is 5 and it occurs at the point that is your x is equal to minus 1. Now similarly, let us discuss another point. Say we have, okay, let us consider another example. Let's say this is your fx is equal to minus modulus of x minus 1 plus 5, because mod of x minus 1 is greater than or equal to 0, minus mod of x minus 1 is less than equal to 0, minus of mod of x minus 1 plus 5 is less than equal to 5, or fx is less than equal to 5. That is fx is less than or equal to f of 1. So this implies fx has maximum value at x is equal to 1 and the maximum value is 5 here. Now once again let me check the previous question. You can see that it is greater than or equal to 0. So where I am wrong? So anyway, let me discuss the previous question once again, because here we are getting the correct answer. I suppose that this is fx has maximum value at x is equal to 1. Now let me discuss the previous question once again. It is fx is equal to, this is your 3x square plus 6x plus 8. So it is 3 times x square plus 2x plus 8 over 3. So it is 3 times x square plus 2x plus 1 minus 1 plus 8 over 3. This is your 3 times x plus 1 whole square plus 5, because it is minus 3 plus 8, that is plus 5, or as x plus 1 whole square is greater than equal to 0, 3 times x plus 1 whole square is greater than equal to 0, 3 times x plus 1 whole square plus 5 is greater than equal to 0. So this implies, is 0 plus 5, fx is greater than equal to, that is 5, or fx is greater than equal to f of minus 1, implies minimum value at x is equal to minus 1. So sorry for the mistake. Now let me once again draw the curve of this, because from here we have y minus 5 is equal to 3 times x plus 1 whole square, implies that is your upward parabola. So how it would behave? So we have x is equal to minus 1. Now x is equal to minus 1 and y is equal to 5. So it is going to be like this here. So you can see here, this function has got only the minimum value and no maximum value, and this function has got maximum value and no minimum value here. Now next is fx is equal to sine of sine x. Now because we know that sine x always belongs to minus 1 to 1, so sine of sine x belongs to sine of minus 1 to sine 1, that is minus sine 1 is less than equal to sine of sine x is less than equal to sine 1. So this is the least value of the function, this is the greatest value of the function here. So we have covered all the 3 examples in which we can see that this function has got, that is the only the minimum value, then here it has got only the maximum value, and here it has got the both minimum as well as the maximum value. Now next is local maxima. A function fx is said to have local maxima at x is equal to a if there exists a neighborhood a minus delta to a plus delta of a such that fx is less than f of a for all x belongs to a minus delta to a plus delta. A function fx is said to have local maxima at x is equal to a if there exists a neighborhood a minus delta to a plus delta of a such that fx is less than f of a for all x belongs to a minus delta to a plus delta. That is, in this restricted interval, in the neighborhood, if this exists, implies fx has local maxima at x is equal to a. So similarly, if fx is greater than f of a for all x belongs to a minus delta to a plus delta, implies local minima at x is equal to a here. Now next is, what is the condition for function to have local maxima, local minima, or the extreme values? Now the necessary condition for fx to have extreme values at x is equal to a is that f dash a is equal to 0. That is, f dash a equals to 0. That means where the derivative of the function at x is equal to a equals to 0, we will have, that is, the extreme values. But this is not the sufficient condition. Sufficient condition in the sense that f dash a equals to 0 does not imply, that is, the function is always going to have extreme value at x is equal to a. So for example, you can see that fx is equal to x cube. If you take the derivative f dash x, you can see that it is 3x square. When you equate it equal to 0, this implies x is equal to 0. But at x is equal to 0, you are not going to have the extreme values. I can show you through the graph of fx is equal to x cube. So this is the graph of y is equal to x cube. You can see that although derivative is equal to x is equal to 0, but it is not the extreme values here, right? So now next we will discuss the criteria for function to have extreme values. How can we find the, that is the, how can we judge the function has got local maxima or local minima? So we have first derivative test. Now first order derivative test to have local maxima oblique minima. Now you can see here, if I plot the graph of the function, some function is like this. So you can see here, looking at the graph, we can see that the function has got local maxima at x is equal to a. Now in the neighborhood of a, now when x is slightly less than a, let's say at this point, you can see that implies f dash x or f dash a is positive because it is making an acute angle. When it crosses a like this, when x is slightly greater than a implies f dash a is negative. So therefore when f dash x changes its sign from positive to negative through x is equal to a implies local maxima at x is equal to a. Similarly, let's say this is the point B here. Now when x is slightly less than B, this is the obtuse angle. When it crosses B, it is the acute angle. Implies similarly, if f dash x changes its sign from negative to positive through x is equal to B, implies local minima at x is equal to B here. So how we are going to find the function has got local maxima, local minima? So what should be the first step? First step is you find f dash x, equate it equal to 0 and get the critical points. What are the critical points? Those points which are obtained by taking f dash x equals to 0. They are called the critical points. After that, apply the wavy curve method to see the change of signs of f dash x. When it changes from positive to negative, implies that makes maxima. When it changes from negative to positive, implies function has got minima at that point here. Now one thing more which I would like to discuss here is say the curve is like this. So many local maxima, local minima, local maxima, local minima, local maxima, local minima, and so on. Very easily through this curve you can see that local minima at a point can be greater than local maxima at some other points. Local maxima doesn't mean that is the maximum value of the function. Local minima doesn't imply that it is the least value of the function. This is the least value in the neighborhood. Local maxima means in the neighborhood of this. Now what is the meaning of local? Local means this is the restricted region here. So local minima at a point, here we have the local minima at a point can be greater than local maxima at some other points here. Now let us discuss these questions. Now first question is find the points of local maxima and local minima of. First is fx is equal to, what is that, x minus 1 whole cube into x plus 1 whole square. So what is the first step? Find the derivative. What is f dash x? It is x minus 1 whole cube into 2 times of x plus 1 plus x plus 1 whole square into 3 times of x minus 1 whole square. Now you take x plus 1 into x minus 1 whole square common. So it is 2 times of x minus 1 plus 3 times of x plus 1. So what is that? It is x plus 1 into x minus 1 whole square into 5x plus 1. Now f dash x is equal to 0 implies x is equal to minus 1 minus 1 by 5. So these three are the critical points. Now you can see that this is the even power of the factor. Even power of the factor, that means it is not to be considered for the wavy curve method. Through this you can see that there will not be any change of sign. When x is slightly less than 1 or greater than 1, it is always going to remain positive. No change of sign here. Now, so we have, what is that? It is minus 1 by 5 plus minus plus. F dash x changes its sign from positive to negative, implies local maxima at x is equal to minus 1. F dash x changes its sign from negative to positive through x is equal to minus 1. So local minima at x is equal to minus 1 by 5. So let us say we want to find the local maximum value, and local maximum value is f of minus 1. Here we have the function. What is that? It is minus 1 cube into minus 1 plus 1 square, which is 0 here. Local minimum value is f of minus 1 by 5. What is that? Minus 1 by 5 minus 1 cube into minus 1 by 5 plus 1 square, minus 6 over 5 cube into 4 over 5 square. So this way we will get the local minimum value. So let us discuss another question. So next is fx is equal to x raised to power 5 minus 5x raised to power 4 plus 5x cube minus 1. What is f dash x? It is 5x raised to power 4 minus 20x cube plus 15x square. So it is 5x square into x square minus 4x plus 3. So it is 5x square into x minus 3 into x minus 1. So when you equate it equal to 0, this implies x is equal to 0, 1, 3 are the critical points. But through x is equal to 0, no change of sign. This is called, when you have a point when there is no change of sign through them, that is called the point of inflection. Point of inflection means where you have neither maxima nor minima, that is called the point of inflection here. So applying the wavy curve method, you have 1, 3, plus, minus, plus. F dash x changes its sign from positive to negative through x is equal to 1. So local maxima at x is equal to 1. Changes its sign from negative to positive through x is equal to 3. So local minima at x is equal to 3. This is the point of local maxima. This is the point of local minima. So that's it. Now further we have fx is equal to, it is 2 sin x minus x when x belongs to minus pi by 2 to pi by 2. So what is f dash x? You can see that it is 2 cos x minus 1 equated equal to 0. So cos x is equal to half implies that x is equal to plus minus 60 degrees, because cos 60 is 1 by 2 and cos of minus 60, that is also 1 by 2. Now in case of trigonometric functions, wavy curve method is not at all applicable. So what we are going to do here? Now if I plot the graph of cos x, you can see that this point is minus pi by 2, this point is pi by 2. Now this value is 1 and this value is half. So that is your, this is your half, this is your pi by 3. Now we know that 60 degree, that is your pi by 3, is the critical point. If x is slightly less than pi by 3, implies cos x is greater than half, implies 2 cos x minus 1 is positive, implies f dash x is positive. And when x is slightly greater than pi by 3, when it crosses pi by 3, let's say it is here, implies cos x is less than half, implies 2 cos x minus 1 is negative, that is f dash x is negative. So you can see that f dash x changes its sign from positive to negative through x is equal to pi by 3, implies x is equal to pi by 3 is the point of local maxima. And similarly we will check that is your, you can see that at x is equal to minus pi by 3 you will always have the point of, that will always be the point of local minima. You can never have two local maxima or two local minima. In between two local maxima there will be local minima, or in between two local minima there will be one local maxima. If this is the point of local maxima, other has to be the point of local minima. But if the same question is asked in your exam, then you will have to prove that at x is equal to minus pi by 3 we have, that is your point of local minima here. Now next is higher order derivative test. Higher order derivative test to determine local maxima minima. So step 1, find f dash x, equate it equal to 0. Step 2, find the critical points. Step 3, find f double dash x. Now at the critical points, if f double dash x is positive, implies local minima at that point. If f double dash x is negative, implies local maxima at that point. Now, if f double dash x is equal to 0 at that point, then find f triple dash x. Now, if f triple dash x at that point is not equal to 0, implies the point of inflection. Now, if f triple dash x at that point is equal to 0, find f fourth order derivative. And if fourth order derivative positive, implies local minima, and if it is negative, implies local maxima at that point here, right? So now we are going to solve the questions using the higher order derivative test. So in your exams, sometimes it might be asked to follow the first order derivative test in particular, or second order, or the higher order derivative test in particular. Now, first question which we are going to discuss here is, we have fx is equal to minus 3 by 4 x4 minus 8x cube minus 45 by 2x square and plus 105. Find f dash x. It is minus 3x cube minus 24x square minus 45x. Now f dash x is equal to 0, implies minus 3x into x square plus 8x plus 15 equals to 0. So this implies minus 3x into x plus 5 into x plus 3 equals to 0, implies the critical points are x is equal to 0, minus 5 and minus 3. Find f double dash x. You can see what is that? It is minus 9x square minus 48x minus 45. F double dash 0 is equal to minus 45 less than 0, implies local maxima at x is equal to 0. Find f double dash minus 3. It is minus 81 plus 144 minus 45. It is minus 126 plus 144 is positive, implies local minima at x is equal to minus 3. Find f double dash minus 5. So it is minus 9 into 25 plus 240 minus 45. How much is that? Minus 225 minus 45 plus 240. Is that negative? Implies local maxima at x is equal to minus 5. So if we want to determine the local maximum value and the local minimum value, that you can obtain by substituting x is equal to 0, minus 3 and minus 5 one by one here. You will get the local maximum and the local minimum values here. Now next is fx is equal to sine 2x minus x when x belongs to minus pi by 2 to pi by 2. Sine 2x minus x. Now find f dash x. It is 2 cos 2x minus 1 equated equal to 0, implies cos 2x is equal to half. This implies, what is that? 2x is equal to plus minus, that is your 60 degrees, or implies x is equal to plus minus, that is your 30 degrees. So whenever trigonometric function is there, it is always advisable to use higher order derivative test, because it's easy to determine the point of local maxima and local minima here. Now you find the second order derivative test. Can I say that it is, find the second order derivative. Can I say it is minus 4, that is your sine 2x, because derivative of cos 2x minus 2 sine 2x. Now f double dash pi by 6, it is minus 4 sine 2 times pi by 6. It is minus 4 sine 60 degrees. Minus 4 into root 3 by 2 is negative, implies point of local maximum. Find f double dash minus pi by 6. It is minus 4 sine minus pi by 3. It is 4 sine pi by 3. It is 4 into root 3 by 2 is positive, implies point of local minima. So this is the point of local minima, this is the point of local maximum. So once again I would like to repeat the fact that it is always advisable to use the higher order derivative test when the trigonometric functions are involved. Let us discuss another example of your trigonometric function using the higher order derivative test. We have fx is equal to sine 4x plus cos 4x. So if I find the derivative of this, you can see that it is 4 sine cube x into cos x minus 4 cos cube x into sine x. You take 4 sine x into cos x common. This is sine square x minus cos square x. Now can I say that it is 2 sine 2x into minus cos 2x, because cos 2x is cos square x minus sine square x. Can I say that it is minus 2 sine 2x into cos 2x, which is your minus sine 4x equated equal to 0. Now in this question the interval which is given to us is, that is your x belongs to 0 to pi by 2. This implies 4x is equal to 0, or it is pi, or it is 2 pi, implies that x is equal to 0 or pi by 4 or pi by what is that, 2. But x is equal to pi by 4 belonging to 0 to pi by 2 is the only critical point here. Sometimes student can commit the mistake by ignoring the negative sign while finding the second order derivative. So what is f double dash x? It is minus 4 cos 4x. F double dash pi by 4. It is minus cos pi, which is your 4 positive, implies local minima at x is equal to pi by 4. You can see how easy it is to find the point of local maxima and minima using the higher order derivative test when the trigonometric functions are involved here. So let us discuss another example of this. Let us say we have fx is equal to sin x minus cos x when x belongs to, that is your 0 to 2 pi. So f dash x is equal to cos x plus sin x, equated equal to 0. This implies what is that? Tan x is equal to minus 1, implies x is equal to, how much is that? It is 3 pi by 4 or it is 7 pi by 4, because tan x is negative in the second quadrant or the fourth quadrant. Now find the second order derivative, which is your minus sin x plus cos x. What is f double dash 3 pi by 4? It is minus sin 3 pi by 4 plus cos 3 pi by 4, which is your minus 1 over root 2 minus 1 over root 2, which is negative. That implies this is the point of local maxima here. Find f double dash 7 pi by 4. It is minus sin 7 pi by 4 plus cos of 7 pi by 4. Now you can see that it is 1 over root 2 plus 1 over root 2, which is positive, implies the point of, that is your local minima here. Now next is absolute maxima and absolute minima. That is absolute maxima oblique minima. So absolute maxima oblique minima implies the greatest and the least value of the function in the interval. That is the greatest possible value and the least possible value of the function in the interval. So what is the criteria to find here is, for example, we have the question fx is equal to 2x cube minus 24x plus 107 in the interval 1, 2, 3. So same way, first of all we will find the derivative, which is your 3x square minus 24 equated equal to 0, implies x square minus 4 equals to 0. This implies x is equal to 2 belongs to 1, 2, 3 here. Whenever the question is to find the greatest and the least value, value of the function, or the absolute maximum and absolute minimum value of the function, then what should be the next step? Find f of 1. 2 minus 24 plus 107. 109 minus 24, which is 84. 5. Find f of 2, that is through the critical point. 2 into 8 minus 48 plus 107. How much is that? 16. Minus 32 plus 107, which is your 75. Find f of 3, this is your 54, minus 72 plus 107. How much is that? Minus 18 plus 107, which is your 89. So absolute maximum value is 89, absolute minimum value is 75, absolute maximum occurs at x is equal to 3, and absolute minimum occurs at the point x is equal to 2 here. Now similarly the next one is, say we have fx is equal to, this is sin x plus half of cos 2x in the interval 0 to pi by 2. Find f dash x. This is cos x plus half of minus 2 sin 2x. So this is cos x minus sin 2x equated equal to 0, implies cos x minus 2 sin x into cos x equals to 0, implies cos x into 1 minus 2 sin x equals to 0, implies x is equal to 90 degrees or sin x is equal to half, that is x is equal to what is that, 30 degrees here. Since we have to find the absolute maximum and absolute minima, f of 0, it is 0 plus half, this is equal to half. F of pi by 6, that is your sin 30, which is half, plus half of, that is your cos of 2 into pi by 6, which is half, plus half into half, which is your half, plus 1 by 4, which is your 3 by 4. And next one is f of pi by 2. This is 1 plus half of cos pi. 1 minus half, this is half. So absolute maximum value is 3 by 4. It occurs at the point x is equal to pi by 6. Absolute minimum value is half, which occurs at 0 as well as pi by 2. So this way you can find the absolute maximum and the absolute minimum value of the function here. Now, next question is, if y is equal to ax minus b upon x minus 1 into x minus 4 has a turning point, at p, which is your 2 minus 1, then find the values of a and b and show that it is maximum at p. So this curve, this function has turning point at p 2 minus 1. We have to show that, we have to find the values of a and b and show that it is maximum at p here. Now curve turns at the point 2 minus 1, implies 2 minus 1 lies on the curve. So therefore minus 1 is equal to 2a minus b upon 1 into minus 2. So 2 is equal to 2a minus b. So this is the relation which we are getting here. Further, dy over dx at x is equal to 2 is 0. So this implies x minus 1 into x minus 4 into a minus ax minus b into x minus 1 into 1 plus x minus 4 into 1 upon x minus 1 into x minus 4 whole square is your dy over dx. So dy over dx at x equal to 2 implies that you can see that it is, this is your 1 into minus 2 into a minus, this is 2a minus b into 1 minus 2, because 1 minus 2 upon, this is 1 into minus 2 whole square is equal to 0. So this implies that minus 2a plus 2a minus b equals to 0. Minus 2a, this will be minus 1, minus 2 minus plus 2a. So this implies b equals to 0. b equals to 0 implies from first a equals to 1. So we have the values of a and b. Now we have to show that this function has got maximum value at p2 minus 1. Now that means you can see that dy over dx is equal to, since a is 1, it is x minus 1 into x minus 4 minus, what is that, x into, this is your 2x and minus 5 upon x minus 1 into x minus 4 whole square. So dy over dx is equal to, this is your x square minus 5x plus 4 minus 2x square plus 5x upon, this is whole its square, upon x minus 1 into x minus 4 and its square. So which is your minus x square plus 4 upon x minus 1 into x minus 4 whole square. So it is minus of x minus 2 into x plus 2 upon x minus 1 into x minus 4 and its square. So this is your 2 here, plus minus, minus plus. That is because of the negative sign. You can see that curve derivative changes its position from positive to negative through x is equal to 2. This shows that function has got local maximum at p, which is your 2 minus 1.